from midnight. We're almost there in early bed, morning time. It's morning. Okay. Okay. So that gives us here integral of sine inverse of x dx. So I'm going to do this also by parts. If you have the integral sine inverse, then it's by part. Tan inverse by parts. So what you're going to have to do, I'm going to say, is easy. So I'm going to say, okay, so this is going to be u, and this is going to be dv. So you see what I'm saying, this is going to be dv. So now, the formula, say integral of u dv equal to uv integral v du. Okay, what is a u? Our u equal to, let u equal to sine inverse x. Du equal to, okay, so when you differentiate, let me write here. When you differentiate sine inverse or sine, or sometimes you can call it arc sine. Let's say f of x. Let's call it f of x. Even g of x, okay, it's fine. When you say sine inverse, arc sine is the same thing. So now when you differentiate this one, it will give you f prime. And then over, write exactly the sine, we know it has to be 1 minus function square. So that's what you got. So we do the same thing. Let's differentiate. Means you have to differentiate the function here, which is going to give us 1. You write on top. If you want to show all your solution exam, you do this. You say x differentiate. This means differentiate, and they say square root for sine 1 minus. Take a function square. What is a function? This one here, which is x for this case. You see what I'm saying? Dx. Okay. When you differentiate x, or derivative of x is equal to 1. Equal to 1. So du equal to 1 minus x squared dx. Okay, now let's go for this one, dv. Okay. Okay, now so we're gonna have to integrate dx equal to dv. Integrate x equal to v. Now substitute the formula. So all this stuff equal this equal to this. Equal to uv. So we have uv. What is a u? Our u equal to sine inverse times v equal to x. So rather write x and then sine inverse. X sine inverse of x minus, okay, minus integral v. What is a v? Oh, v equal to x. And then du. What is that? Du equal to du. Oh, this one here, which is going to be it's like 1 times. So 1 times x is just x. Okay, over 1 minus x squared. Okay, dx. Okay, so this is substitution right here. This is a substitution. Okay, so let's do substitution. So I can just let u, let's let u equal to 1 minus x squared, 1 minus x squared. Differentiate this d, u equal to, and this is going to give it negative 2 x d dx. But this x dx equal to x dx, I can just divide by negative 2. So divide by negative 2 means negative 2 is going to come this side. So x dx means divide by negative 2. X dx equal to du over negative 2. So now I can replace this. I can just say, okay, so this is going to become, I'll just do it here. So this is going to become like minus integral, okay. X dx means this is going to be u over negative 2. So du, negative 2 underneath means it can go to the back. It's a 1 over negative 2. But negative and negative is going to be plus. Here you have x, okay, sine negative x plus, okay, half du, okay, because the u over negative 2 is going to come here, but negative is going to make it positive. Now 1 over this is like square root of u, because square root of u now, because this is equal to u. Now we can integrate this. Okay, this is like u negative a half, negative, because it's going to be a half, go to the top, negative a half du, and then plus 1 because you integrate is going to be u a half is square root, and then that same half is going to come at the bottom, which is going to make 2u. So 2u means like, okay, so I can just come and plug here. So I can say 2u, okay. So all this stuff is going to be 2 and the square root of u. But we know u. What is a u? Our u equal to 1 minus x squared. So it's like 1 minus x squared. 2 and 2 is going to cancel. This and this cancels. So it's like 1. So it's like this is what we have. Okay. So when do you have a limit? No limit. There is no limit. But if they say, for example, 0 to 1, you substitute here 1. Let's say 0 to 1. Let's say, for example, say 0 to 1 means I'm going to say 0 to 1, and then upper limit minus lower limit. That means upper limit minus lower limit, meaning, okay, so then I'm going to say upper limit means 1 substitute everywhere. Upper limit throughout, it's going to be 1 sine 1 plus, okay, 1 minus 1 square is 1 equal to 1 minus 1 equal to 0 square to 0 equal to 0. Okay, so this upper limit. Okay, minus lower limit. Lower limit takes 0. So 0 substitute 0, 0. 0 times anything equal to 0. Plus 1 minus 0, 1. Square to 1 equal to 1. So all this has to give us 1. Okay, sine inverse of 1. Go to sine inverse of 1. Which changes there? Sine inverse of 1 equal to 90. Or you can say power over 2. So it's going to be power over 2 minus 1. Final answer. So we done with that question. Now, okay, let's go to another new page. Because I want to be done with it. Okay, let me write the question again here. Okay, so question number 74, they say integral of course, x, and then we got sine 5x dx. Okay, 75. 75 again now. 75, they say integral sine 6x cos 3x dx. 76, we got integral sine 2x cos 2x cos square x dx. Okay, now 77, let me do here 77 integral sec 9x tan 5x dx. 78 integral sec dx. Okay, and then 79 integral of sine 2x over 2 plus cos x dx. 80 okay, question 80. Okay, cool, this one is done. Copy the question, right? Okay, now this is okay tan. Okay, this is arc integral of arc tan. Okay, arc tan 4x dx. Okay, 81. Okay, integral tan inverse of 6x dx. 82. Okay, integral of cos inverse, or you can say cos is the same thing, cos inverse. Okay, cos inverse of let's say x squared dx. Okay, 83 integral of arc cot ex dx. Let's say ex 2x, ex power 2x. Yeah, ex power 2x. Okay, 84. Okay, 84 arc sine 3x arc sine. Okay, yeah, arc sine 3x. Okay, 85 okay, integral of t sec square 2t. Okay, 86. Actually, right here, our space coming enough. Oh, let me write here. 86. Oh my God, the space is coming enough for my concern. The space might not be enough. Okay, 86. Let me just write only 186. Okay, 86 tan x cube integral of tan x cube dx. Okay, 87. So this question 87, say okay, integral sec square ex dx. Okay, now 88. Okay. Let me just do this one first because the space is the problem is the space. Okay, now let's go. So this question here is easy. So if I finish this means I'm in question number 88, 87, 87. So if I finish this, let me write here so I will remember 87. Sometimes I don't go in order. Okay, so if I finish all this question means I'm in question number 87. Now let's go. So I can start with whichever. Let me start at 87 so I can have some enough here. Okay, enough question. Okay, integral of sec square ex dx. So just remember, if you integrate sec square of a function dx, this give us tan. Give us 1 of a derivative of a function. Means you must derivate this function the right under, and then you get tan of exactly the same function. No limit, so you plus constant. So same here. Means I'm going to say this is 1 over derivate this function. You derivate ex, okay, let's say 2x for example. If you derivate this, it's going to give you 2e 2x, and then when you integrate the sec, you get tan. So I don't need this one because 1 times anything is just 1. Tan of e 2x plus constant. So we're done with this question. Let's go to the previous one. 86. Question 86. So tan x cubed. Okay. So if you integrate tan of a function, let's say g of x dx. Okay, this is 1 over derivate this function, and then you get x prime, g of x prime, and then when you derivate tan, what do you get? Sec square. Yeah, when you derivate this, it's going to give you sec square of a function. Plus c, okay, plus c. So now this is going to become 1 over derivative function. What is it? Tan. This one. Derivative x cubed, you get 3x squared, and then you're going to get sec of your function. What is the function? Our function is x cubed plus constant. So we're done with these two, and then we move. So I'll just make a space here. I did that for a reason, so I can have some space here. Okay. See if it record. Yes, it does record. Okay. Now let's go. Okay, now I'm going to do this all question in 7 minutes. I'll be done with them, all of them. Quick, I'll be speed now, because I never show you my speed before. Okay, cool. Now, whichever one you want me to start with. Okay, let me go with the flow now. Okay, 77. Question number 77. Oh, let me start with this one. Okay, 74. It doesn't matter. When I finish this, I'm in question number 87. Okay. Now, integrate this. So what I'm going to do, nobody tell me, but I have to use a common sense. I'm going to have to separate this because I know, okay, this is, okay, I see. So, nobody teach you, but you got to use a common sense. So, I know I'm going to put this cos x dx. And then take this sine 5x before. You know why? Because I know if I let u equal to sine x, and if I differentiate, this is going to give me, when you differentiate sine, you get cos x dx, which is this. It's going to become du. So this time we say integral, we know sine equal to u now. So it's going to be u power 5, and then all this equal to du, because du equal to cos x dx. So this is going to be du. So now when you integrate, you add 1, and then the same thing right at the bottom, which is going to be 6. So it's going to say u power 6 over 6 plus constant, because there's no limit. So what is our u? Our u equal sine. So say sine power 6, 6x over 6, and then plus our constant. We're done. We go to the next question. So that question is done. We go to the next question. You see what I'm saying? We go to the next one. Next question. So the next question, not all the time you must do the same trick. Every time you have to look at it. The more question you do in regular. So when you do on a regular, means you get used to the question, because they always flip around the question. Okay. Now integral of that. So nobody tell you now. I'm thinking, okay, how am I gonna split that one? I can do the same trick. I'm gonna use sine 6x. This one I'm gonna take 1 cos from 3. 1 cos dx, and then I'm going to let you 2 cos, means cos square x. But from trig identity, I know cos square x equal to 1 minus sine square x, and then here we have a sine power 6 or x, and then we got our integral in the dx. Oh, cos x dx. So if I let again, like how I did u equal to sine x, so du equal to cos x dx. So this is going to become du and everything u here. So this is going to become integral u power 6. And this will be 1 minus u square, and then this will be du. Now, put it in, so this will be equal to, okay, u times 6 is u6. u6, if you integrate, means you add 1, it's going to be u7 over 7, and then there's a minus. This going to be u6 times, u6 and because you multiply this same base, you add, it's going to be 80. 80, when you integrate plus 1, it's going to be u power 9 over 9 with plus constant, because there's no limit. U, we know the value of u equal to sine. So sine 7x over 7, and the minus sine 8x 10, 9x over 9 plus constant. We're done with that question. Now we go to the question number 76. You understand what I'm saying? So now we go to question number what? Number 76. Okay, like I say, now I'm going to be going speed. Okay, 76 is the same again. Okay, 76. So now, oh, this is another one now. So if they give it both even, you see here is like even, odd, even, odd, even. So you do that tricky. But now you see the both even power. Sine, growth sine, and then I give you cos x dx. So how I'm gonna go for this? So this you have to know double angle of sine and cos. So now I know for effects, if somebody give me, so let me use another pen here. If somebody give me, let's say cos, double of my angle, this let me say, if I want everything else to be cos, this let me say 2 cos x minus 1. Okay, 2 cos square x. So if I had to replace this cos square x, means let me make this subject so I can make it, so I want to make this subject so I can replace. So cos square x, take this one here, it's going to become cos 2x plus 1 and then over 2 equal to cos square x, make subjects. So I can replace this with that. Same with sine. This formula, which is cos double angle, sometimes you can write it as 1 minus 2 sine square x. So I want to replace this sine square x.